Hello everyone, this is Mohammed Yaqub and it's time of the week again for another STM32 tutorial video. And today's tutorial, I'm going to show you how to connect a USB flash drive to the STM32F4 Discovery board. And for any STM boards generally, anyone comes with the on-the-go USB. Alright, so in today's tutorial, I'll show you the basics of how to open a file, how to connect a USB flash drive, how to write to a text file, and how to read from a text file using the flash drive. So let's get straight to the point and open CubeMX and set up a mass storage composite project. And on CubeMX, click on New Project and select the right board. It's the STM32F4 Discovery that I'm using. So Discovery board of type of 4, and it's this one. Right, and first thing we do in here as usual is that I'll clear all the pins, enable them myself. First thing I want to enable is I'll enable my LEDs because I'm going to use them in this demo. So PD 12, 13, 14 and PD 15. And I would like to give them a label as well just to ease the programming. So this is LED 1 and it will appear in my main as LED 1. This is LED 2. It's quite useful. Then this is LED 4. And I'm also going to enable my push button on PA0 and set this to GPIO input. And I'm also going to give it a label. I'll call it button. Okay, and then next thing on my guideline, my tutorial steps is that I need to enable the USB on the go, host only, and then the VBus. So need to enable USB on the go and set the mode to host only. And we need to enable the VBus. This is for applying voltage to the terminal because we are using host. So we are plugging the USB flash drive, and the USB flash drive doesn't have a power. So we need to provide it with a power. And that's why we need to enable the VBus in this case. All right. And next thing is that we need to go to the USB host or middleware section. Then class for FS. Select mass storage host class, and then on FATFS take the USB disk so that we enable file system for USB disk. Alright, and the next thing we need to do is that we need to enable the external oscillator to provide a very stable clock for the USB. So go to RCC, expand it, and select the ceramic resonator, and this will enable the external clock. And then we need to, there's one more thing we need to do, is that if you go to the STM32F4 Discovery user manual and look at the USB schematics, so scroll down towards the end and look for USB schematics, this one, on figure 13. You'll see that in order to enable power to the VBus pin that will provide 3 volt to the USB stick, we need to set PC0. This is a pin on the STM, and this goes to the enable of the power switch to provide power to the USB terminal. And this is active low pin. So we need to enable PC0 and set it to low in order to enable power to the USB. So let's do that. So PC0 needs to be enabled and set to GPIO output. And let's go to configuration and just make sure GPIO is on low state. And sure enough, its level is low by default, so it will enable power now. All right. And back to my steps. Need to increase the FATFS parameter. Exactly. So that will be when you go to the FATFS middleware configuration section. Scroll down till you find the maximum sector size. Make it to the maximum. We have minimum to maximum so that we allow a larger sector size. Okay, and then back to the clock configuration where we need to set our clocks. Since we selected the external oscillator, we need to enable it, use it as a source, and then I'll set the system clock to 84 megahertz, and it should automatically sort out all the other ones. Perfect. And the most important one for this demo or for this application is the 48 megahertz clock, because that's the one that USB uses. Okay, and then on my steps, that's everything on CubeMX, so we are ready to generate the project. So click on generate source code icon and give the project a name. I'll first select the project location. I've already copied my path where I want to store it. So I want to store it to this location, and I'll call it USB Flash Drive tutorial. And select the right IDE that you want to use. I want to use MDK ARM v5 or Keil 5, and then select your middleware or firmware package. I prefer to use 1.16. This is a very stable one where I do most of my coding on, and I really like it. Never had a problem with it. Unlike some of the latest versions where I do struggle, there seems to be more bugs. Not sure if they fixed a lot of them now. So I will also include this down in the description of the video, firmware 1.16. Some people seems to request it for my latest tutorials, so I'll add it to my description too. Alright, so that's everything here. Click on OK, and this will generate the source code. And while this is loading, for any of my business contacts, you can get in touch with me through mutexembedded.com, and you can send me a request there. But for the time being, let's wait for this one to generate the source code, and then we'll go to Keil and start programming. Alright, source code is generated successfully, so click on Open Project, and this will take you to your IDE. Okay, on Keil, the first thing to do here is to open the main, and I'll implement a simple code to test the USB status update. So what I'll do is I'll write a shortcode that turns the green LED on whenever you plug the USB flash drive, and turns it off when you disconnect it. So to do that simple thing, you need to open USB host.c, and we need to copy this application state variable to our main as external so that we can see it in the main. So in private variables, perhaps set it as an external variable because it's already defined somewhere else, and I'll do a simple state machine into my infinite while loop. And by the way, this function max USB MX USB host process, this one that does the status update of the USB. So things like when the USB is idle, ready, plug, disconnected, start, and so on. So we'll do the switch case, and we are doing it for this variable application state, and we'll implement all the cases. So case 1 is when this one is equal to idle, for example. Let's try to go to the definition of this, but I need to compile the code. So let me first compile it, and then I'll get back to this and do the switch case. Alright, so let's leave it compiling for a few minutes. Alright, code compiled without any errors. Now let's carry on with our tutorial. So I said I want to see all the status, all the possible switch cases. So go on this application idle and go to definition, and this will give you all the enums. So this one is an application type def enum and has got all the status. So idle, start, ready, disconnect. So I'm going to implement all of these cases. So for case 1, and then break. Case 2 is when the USB is on start. And then when it's ready, so that's when it's completely plugged and ready for anything you want to implement with it. And finally, when you disconnect it, it will go to this state. Alright, and basically what I want to do here as a starting point is that whenever USB is plugged, it will directly jump to the start state. So here I want to turn green LED on. So using the HAL library TPIO functions. So HAL TPIO write pin, and that's my LED one. And the reason why I get the port and pin labels is because I did label them as LED ones in CubeMX. That's why they appear in here. If you haven't labeled them, then you would have to stick with the TPIO port and pin numbers as they are. So LED1 is LED1 GPIO port, and the second parameter is LED1 pin. Alright, and then the status, so GPIO pin set, we'll turn the LED on, and then when you disconnect, when you remove the USB flash drive, I'm going to turn the LED off. Alright, so the state will be reset in this case. And that's it. So let's compile the code and test it on the board. Alright, plug into your Discovery board and upload the code. Alright, perfect. As you saw on the short video, it did work. When I plug in my USB flash drive, LED turns on. When I disconnect it, LED turns off. Right. Next thing I'll show you in my tutorial is that next one is we want to mount the USB flash drive. So this would be, as we plug it in, we want to mount it by software. So link it to the FATFS library. And to do that, we first need to add a variable, the FATFS file system variable. So I'll call it my USB FATFS, and this needs to be defined somewhere outside the main. So I'll define it in here. I'll call it my FATFS variables. Basically, this variable is of type FATFS, and I'll call it my USB FATFS variable, anything really. And I also need to, since my if mount function, the function that mounts the USB, uses the FATFS variable and also uses the USB path. This is the logical path defined in the libraries. You'll find it in the fatfs.c, and I need to define it in the main as external variable to make use of it. So open the fatfs.c file, and you'll find it here at the top. Just copy it over to the main, but with the extern thing. So this one is the USB-H USB logical path. So add extern at the beginning, and this variable now will be seen in the main. And the routine is very simple. So at the application start, when you first plug the USB, we just want to mount it up. So we use this function, and then we'll turn the LED on if the mounting is successful. So let's do that. So the function is if mount, and we'll do it in the start. So instead of just turning the LED on, we'll first do the mounting. So if mount, and the function takes two parameters. The first one is the fatfs variable and a pointer to that. So we put the ampersand sign, and the second parameter is the path variable, I believe. Yes, it is. So we also need to typecast this to t character constant, because that's the type that the function expects. When you go to the definition of the function, expect this type variable. So we need to typecast it to the similar type. So this one, and then we add the path, USB-H path. And then the last parameter is whether you want to mount it immediately or whenever it's ready. I'll just put 0, so that will be mounted whenever it's ready. And then if this one is equal to OK, then I want to turn the LED on. Alright, so we'll put this one inside the condition block. Perfect. So it will be very similar to what we have previously. Now, when you plug the USB, this will be mounted, and if it's successful, then it will turn the LED on. When you disconnect it, it turns it off. So let's compile it, load it to the board, and do another test. Great, it did work as well. We mounted it, we get the LED on. We disconnect it, LED turns off. Right, next thing I want to show you is that I'll show you how to write a text file to the USB flash and how to read a text file from the USB flash. And to do that, we first need to define some file I/O variables. So there are variables that you need to define so that you open a file and then see the result of the file operations like if open, if close, and if read. And there are the bytes written and bytes read for the write and read functions. And this is a temporary buffer to store your data to be written to the text file and the data read from the text file. So I'll first define these variables at the top of my main so that I can use them for the next operations. So I'll just copy them over so that I don't waste more time, and I'll add this text file down in the description of my video so that you can follow me step by step, and you can pause the video if you think I'm going really quick. So I'll copy this variable over to my main, and I'll add them here at the top. All right, very basic variables. And then let's implement the file write function. Before we be able to do the USB write function or the text file write function of the USB flash drive, we first need to include two library headers, the string library and the Boolean library, because we're going to make use of them in the following. So let's add them into my main in the include section. Superb. And then now we need to define the function prototype for USB test write, and we'll define it at the top in our main. So this should go into the private functions section, prototypes. Okay, that's for my write function, and let me also do my read function on the go. So, and that's for my read function. Okay, so the write function is very simplistic, doesn't take any parameters. This is just a test write and this is a test read, and it returns Boolean variable. So when the write is successful, it will return 1, and if there's any error, it will return 0. So you can check for the status and then accordingly swap your LEDs. All right, now let's go ahead and write the function body of the test write function. Let's do that. Need to copy the function prototype down in begin number 4, where I'm gonna go ahead and detail the body of the function. As in my steps and guideline, the first thing we need to do is that we need to open a file for write. Okay, so to do that, we're gonna set this in here, remove the semicolon. So open or create file for writing. So that we need to use a function called fopen, part of the Fatovs middleware, and the first parameter it takes is the file pointer. So we have defined a variable, file IO variables generally at the top, and this one requires the file pointer. So my file, I called it, and a pointer to that. And the second parameter is the path, is the name of the file. So maybe test or test2, since I think I have a file already stored in my USB flash drive called test. So test2.txt, and then what's the operation for opening? So it's going to be writing. So if a write or create always if the file doesn't exist. Perfect. And I want to check if this one is okay, then I'll carry on. If it's not, then I'll return the error. All right. So let me set an if condition here. If this one is not successful, so the exclamation mark in equal, which means not. If this one is not okay, then I want to return the function with an error and not continue with the rest. And if everything is okay, then I carry on. Okay, so we'll carry on, and that would be next step is that I'm going to copy some test string to my variable that I called using sprintf. So let me show you how it's done. So now copy test text, I know that's very difficult, to my temporary read write buffer that I defined at the top initially. So the file IO variables, part of them is a temporary buffer, so that's the one. This is the read write buffer. Okay, I'm going to use it now to add text to it, and we use a sprintf for that. This is a string function, sorry, addition letter, storing in this variable, and I'll say hello from STM32F4 Discovery, maybe. You can write anything you want. All right, and now we can write it to the text file that we just opened. So write to text file using if write function. Okay, and this function takes the first parameter is similar, it takes a file pointer, and then the second parameter it takes is a pointer to the data variable, and I think the type this function expects is, so we'll go to the definition of this. It expects a constant void pointer, so we'll do a constant void. So constant void pointer, and we pass this variable. And the next parameter is the length of the data that you want to send. So that will be the length of the string. So making use of string length function to count the number of characters in this string. And then next parameter is, that's the last one, is a pointer to the bytes written variable. So this will store the number of bytes that are written successfully so that we can keep track of them for debugging. And I already defined a variable for this that I called bytes written of the type uint, and that's just the type that the function expects. If you look in there, so it's uint, that's the type of variable that the function expects. So and I want to check if this one is successful, I carry on. If it's not, then I return an error of the function. So if this one is not, if r okay, then I want to return with an error. So return an error flag of 0. If everything is okay, then I carry on. All right, and then to carry on, and also part of the check is, no wait, I'm sorry. So that should take a result first, because I'm also checking the write, and at the same time I need to check the number of bytes. I need to do 2 checks. So that's why I'll make use of my result variable that I defined. Part of the file IO variables is the if result one that stores the result status of any file IO operation. So not that quick. I will just store the status, and then if result is not okay and or bytes written is equal to 0. Let me just put brackets just to control the operations. And also, if bytes written are equal to 0, so if nothing is written, then I know there is an error, so I'm going to return an error. Otherwise, I will continue normally. Okay, so now having written them successfully, now I can close the file and return success flag. Okay, so just copy over. So if close is a function that closes the opened file, and that takes the my file pointer too with the ampersand sign, and then I can return 1, the happy flag. All right, so that means success. All right, that's it. So let's go ahead and test it in our main. So copy the function and call it over in there, and I want to call it in my ready state. So when everything is ready, it's start and mounted. I want to set a condition on my push button. If my push button is pressed, so if hull GPIO read pin, I want to read my push button status. Since I labeled it, so I can just write button and it will automatically tell me the port. And then my button pin, if this is equal to GPIO pin set, if it's equal to high, then I want to write to my text file, do my test write function. I'll set a delay of 1 second, just not to do the overwrite again while I'm pressing the button. And I want to test if this one is equal to OK, then I'll turn my LED on. So if this is OK, then I will GPIO bright pin. I'll set my second LED perhaps, so LED 2, or let's say LED 4, the blue one. Okay, then I'll set my blue LED to high. If this is successful, otherwise I'll set the red LED indicating there is an error, and the red LED is the third one, LED 3, and that's the one I label it in here 3, which is BD14. So let's just double check with our guidelines. So that's the way to implement it. Yep. Let's go ahead and test it. So let's compile the code, load it to the board, and we'll do a test with the board. So what we should expect is that when you press the user push button, we expect the blue LED to come on if the operation is successful. And then we can plug the USB flash to my to your computer and see if the file test.2.txt is written with this content inside. Okay, compiled without any errors. Now let's load it to the board and let's test it with the board. Alright, perfect. Seems like successful according to the LED. Now let's plug the USB flash drive to our PC and see if the file is written. Alright, so that's USB flash drive. Open. Exactly, we've got test.test2.txt. Let's open it. Sure enough, hello from STM32F4 Discovery, just like what we've written in here. Alright, superb. Now let's unplug it again. Now next thing I want to show you is how to read a text file. That's very straightforward, very similar steps. So let's continue with the tutorial and I'll show you how to do the USB test read function body. Okay, so we have defined the prototype at the top. Let's copy it over and start writing the function definition. Alright, very similar to the function, to the write function. First thing is that we need to open the file, but now for reading instead. So let me just copy this to save time. Now we're opening the file for, oh, that's an M, should be an N, sorry. So opening file for reading this time. So you don't need the FA write, you don't need the create always, you need to FA read. Okay, and you can so the text predict is you click on control space and I will show you the prediction. So I want FA read, and then so if the file is opened successfully, then we continue. If there's an error, then we return an error flag. All right. And then we can do FA read to read the content of the text file. So very straightforward according to my guideline. But I'm doing a special read type. So I'm reading according to the length of my buffer. So since my temporary buffer length is 100 bytes, I set it to 100 bytes of length. Then what I do with the read function is that I'm reading the file byte by byte until I get to the null character, which marks the end of the string. Then I stop reading. So let me copy this thing over and I'll explain it to you step by step. Okay, so what this does is that it reads from a text file till the null character, which marks the end of the string. So if read function is very similar to fwrite. It takes a similar parameter, my file, and then it takes the buffer to the pointer in which you want to read data to, and then the bytes. Okay, so I'm going byte by byte, so index by index, from index 0 to index 99, and I am reading to the temporary buffer, first starting with index 0 and then incrementing according to the for loop with an I. So I will, each byte will write it to the next element in the array, and it's doing byte read. So the fread function, let's just make it very, very simple. It takes a pointer to where you want to read data to, and then the size of data, and I'm reading byte by byte. And I'm checking each byte I read. If it's equal to 0, which means the null character in a string, then I will stop. I will break the loop and I will keep track of the number of bytes read, which is equal to the I of the for loop. If you didn't get that, don't worry, you can always just copy the code from here and then spend your time try to understand what it does. You can experiment yourself. It's very straightforward, not difficult really. And then if the bytes read are equal to 0, then we know there's an error, we haven't read anything, and this will return an error. Otherwise, everything's successful and we're going to return 1. That marks success. But before that, we need to close the file, of course. So we need to close the file. All right. And a closing file is very similar to what we did with the write function. Now we're returning one to mark success. So that's everything for the read function. Let's compile the code and let's first also copy it to the main so that we can implement it. So we'll do it in a very similar way. We'll do it in the ready state. When you press the push button, instead of writing the text file, it will now implement the USB test read function, and it will turn the blue LED on when the read operation is successful. But we're also going to get to debugging mode and read the temporary buffer and see if the text is read successfully that is stored in that text file. Alright, compiled without any errors. Now let's load it to the board and we'll do a quick test with the board. Right, amazing. Looks like it's successful because we got the blue LED on. Now let's go to the debugging mode and see the data that are read. So navigate to debugging mode while keeping the USB flash drive connected and everything. Okay, and on debugging mode, I want to add my temporary buffer variable to watch memory so that I can see the content. So highlight it and right click and add to watch 1. And expand this a little bit so that I can see the content that will appear in here. That's everything. Let's make sure there are no there are no breakpoints. So kill all breakpoints and run the code. And when I press my blue push button, sure enough, I get the hello from STM32F4 Discovery, and that's just the text stored in my text file. Alright, that's it. That's everything I want to show you at this video. That brings me to the end of the tutorial. Thank you very much for watching. And as always, if you found it helpful, don't forget to hit like and subscribe and maybe recommend it to a friend. And for any of my business contacts, you can get in touch with me through mutexembedded.com. Thanks for watching, and I'll see you in the next video.